This is Algebraic Thinking and Mathematics. My name is Stephanie Kidd, and this is Ms. Vonda Adams. We're the math consultants here at KVEC, and we're going to get started with what does algebraic thinking look like overall. So what is algebraic thinking? Algebraic thinking includes recognizing patterns, analyzing those patterns, understanding and studying what comes next in those patterns, seeing the relationship of problems as they build, and we're going to notice that, making generalizations and analyzing how things change. Now, when we talk about generalization, that's a word it's kind of broad for most of us. Basically, it's the product or the process in which we go through, which sometimes can be, we don't want them to know the structure or the, what do we call that? We don't want them to know the structure first. We want them to actually be able to think about the problem in general. So there's no procedure. Yeah, I was losing my words there. So we don't want them to know the procedure at first. We want them to try to work their way through the problem. We want them to understand that. So getting away from that procedure and really showing them things with the manipulatives, very similar to Vonda and Chastity's last one on doing multisensory. That's what we're kind of doing today with algebraic thinking. And then to, of course, notice that pattern and then how the tendency to respond the same way. Even though it's a different problem, I can use the same process that I had before. So, we won't push that. That's not what we want. All right. Equal means balance. For many of our kids, they see an equal sign, they think it's an answer, but it's actually a balance. So we have to teach them that this is all about a balance. One of the things that we use, and you can see here, if you're looking at our picture, is a balance beam. But if you're looking here, this is the balance beam, and this is one of the things that we will use for algebraic thinking.
It's a really difficult concept for some of our kiddos to understand, and it starts in the primary, that misunderstanding of the equal sign. So we really have to bust that myth and really hit it hard early on with our kids, so they can be successful when they do get to the level where they're working on algebra.
Absolutely. So what does algebraic thinking look like in the primary grades? We're going to just jump right into that. So what does it look like in the primary grades? And Ms. Vonda is going to talk about what that looks like for her.
Okay. My kiddos, my background is algebraic thinking. Is primary. Sorry, that distracted me. Is primary, and so we do work on algebra in the primary. We may not call it algebra, but we work on those concepts. We work on it all the time. For example, with unifix cubes. With unifix cubes, there's a little activity that I like to share all the time called Snap It. And with Snap It, you just take the cubes. Let's see, I've got 5 here, and I put it behind my back and I snap it, and I see that I have 2. So how many are behind my back? Well, that's that missing add-in. Missing add-ins is the beginning learning of algebra. The concept of algebra is what's missing, what we're looking for. What is that space standing for? Now, in the primary, we don't use the letters, but we do use, like for example, I had 2 and what equals 5. I knew that I had the 5. I had 2 in front of me, so what was behind my back? That missing piece is introducing our kids to algebra, those missing add-ins. And another thing we need to be very careful about is making sure that we don't always present our problems this way. For example, in the one I just had, I knew that I had 5, and I know that it is equal to 2 plus some more. So we have to really help the kids understand that this equal sign means that whatever's on this side is equal to whatever's on this side. So that means that we may have to, and we need to, pull out those tools and build it and show the kids. We need to show them that 5 is the same thing as 2 and 3. And they may need to build it and prove it to themselves. Push that together, lay them side by side to see that yes, they are equal. And they'll need to do that many, many times in order to really solidify it and make it secure that they have that good understanding with that. Also to be done with the balance that we have here.
So here's 5, and then we know that we have 2, and we notice that this balance is a little bit off, but if we add 3 more, they are now equal.
And so it's really, really important that the kids get an opportunity to explore with these types of tools. And to, there's actually the type of balance where you can actually put the counters, lay the counters on top and make them balance out. We have, that's called a primary balance. You could use that with the kiddos early on. And I'm not saying that these concepts can't be done with older kids. You have to meet the kids where they're at. If you're working with a child that really doesn't understand what that equal sign means and doesn't understand balancing those equations, then you may need to back up and do these types of activities with them. There's nothing wrong with that. The concept is what we're trying to understand, not working with big numbers. We're just trying to get them to understand the concept of being balanced, okay? Now, also in the primary, we could use the bead string.
I do want to back up and say one thing. If I have a student and they're going 5 and 2 and they see this problem and they put this as 7, using this balance here is actually very good, because what I can do is I can say, look, you said 5 is equal to 2 and 7. And we use that word and interchangeably, right? Because it's putting those together. So if I say that and I demonstrate 2 and 7, is this equal to 5? And they can see that at that point that no, that's not equal. So apparently when I say that 2 is equal to 2 and what number is equal to 5 here, that's going to help this to balance out. And so at that point they can come back over and say, oh, it's the 3.
And of course we see this lots of times as fact families and that kind of thing, and the kids will sometimes memorize those types of things and it becomes a pattern. That's not what we want from our kiddos. We want them to have a good understanding. The only way they're going to get that good understanding, and the only way that you're going to know they've got that good understanding, is if you require that they build it. So that's where I want to introduce our work mat, and this work mat can be used all the way up into algebra, because Miss Stephanie has lots of activities that she actually does with this work mat. So, for example, let's model another problem. And I'm going to go ahead and write it through this 3rd stage, which is the abstract. And let's look at something just a little more in depth. This is something that your kiddos will see lots of times. Something like this. And like Stephanie said earlier, what they'll want to do, I mean, it happens all the time. I've seen it. 33 years of this, I've seen it many times. They'll add all the numbers up and put the answer right there. So their answer would be 9, because they add 2 and 3, and then 4 more makes 9. It's almost like when you give them a word problem and they go through and they find all the numbers and add them up without really having a good understanding of what the questions and what the problem's even asking them. So they can prove it.
Look like on the balance, but what you got to ask them is, this is on one side of the balance, right? So here it is on this side of the balance. This one is actually on this side of the balance. So is that 4 and 9 that you just gave us for an answer correct?
Yeah, and they could prove that it's not balanced. They could actually explore with it and see what would make it balanced, okay? So in order to solve that problem, they'd start out with their 2 and 3 on this side. They'd put a 4 on there, and then they would explore to see which number they could use to balance that equation. So it can be done that way with the tool. It can be done this way with the tool. You can have your 2 and your 3, which is on this side, and you can have your we don't know number and 4 on this side, okay? And like I was showing earlier, then that moves us into that semi-concrete, but they actually can do the drawing of it. So let's do that drawing of what we see. So they do 2 and 3, and then we would do 4 and we're not sure what's here. So I'm going to do a big old box here to stand for that big old box that's in my problem. So when we start that working to see what would make that balanced or equal, then we can actually do some building here. We can show 5 this way, push these together. So what do I need to make it equal or balanced? I need one more. So I actually just need one inside my little box. Okay. But of course, I probably should put that in a different color so it'd stand out, my box. Okay. So that's just a way to use this work mat, a way to use these tools. You can do the same thing with the bead string. You can look at the same concept, just making it balanced, working with making it even on one side, one on one side, and one on the other side. This actually works really cool to do that, to balance it out this way, as long as we're working within the 10.
Another thing is if you're working within the 10, what you can do is for what she had to this is use 2 10 frames. And so up here she had 2 and then 3 more, and she could actually put these in a different spot on the 10 frame if we wanted to. So this is 2 and 3 more. And then here we know we have 4. So if I'm putting my 4 up here, that's the number I know, then how many more do I need to make these balance? I would need 1 more.
So it's all about many times, many ways. We use lots of different tools. We explore the same concept, the same idea, the same whatever we're trying to teach our kiddos. We do it with many different ways. That's what it's all about.
Exactly.
And so algebra does start in the primary, and the kiddos love it when you tell them they're doing algebra. And that's actually what they're doing. But they're looking for that missing add-in, or in multiplication when you're looking for that missing factor.
So the next thing that we worked through all those? All right. So our next thing that we're going to talk about is some algebra, starting with probably in the 6th grade. Okay. So we look at our standards, and standards starting in 6th grade start talking about integers and 0 pairs and those kind of things. But we're going to go ahead and move on to the addition and subtraction of integers. And the first thing you see there is, well, that's just a regular math problem. I want my kids to see that. You know, that's one of the things I want them to see. And so I love using 2 color counters, especially red and black. One, red is always negative numbers and black is positive. So in this case, this is positive, and you can relate this back to if I'm in the red, I owe somebody money, and if it's black, then that's the money I have, okay? Because our checkbooks, typically if they're in the red, it comes out with a little red negative right in front of it, so that's what we want. All right, so in this case, when I'm building these, and I'm going to build these with a lot of things, but if I'm building these, this is 3 and then 2, right? So that would be the first one. And so I could build this easily with 3 and 2. Now, if you're using the counters, what you'll do is you will not use, of course, red's negative. So you would have this for your counters. There would be 3 and 2. So we're using, again, they need to be on the yellow side. So that would be modeling this one. And I would do that. I would go ahead and model that one. They would see that it's 5, all right? And so I would write down that this is 5. So they would have 5 here. Of course, I can do this with the bead string too, because I'm just using this side because, again, positive, negative. And if you notice, one of the great things about a bead string is you can talk about that the 0 is not really there. So your 0 would be your finger and you're just moving them across. And then when you get to the 0 pairs, you can pull them off. So that's real easy too. So one of the things that I like for the bead string is, here we are, here's 2 and, well, it should be 3 and 2 more, and there would be my 5. Now let's talk about the next one. So this one's a little different. We've got 3 plus -2. Now, one of the things I talk to our kids about, 0 pair is so important because we need to know where 0 is, okay? And so 0 pair would be this right here. We have 2 negative, 2 positive. These 2 get together, it's kind of like a positive and negative. They kind of disperse themselves if we're looking at batteries. So this would be 0, this would be 0. So that they cancel each other out. That's what we want them to see.
It's kind of like if you owe someone $1 and then you find $1, well, you're going to have to, if you do the right thing, you're going to give that $1 to whoever you owe the $1 to.
Yes.
So it's kind of canceled each other out. So you're at 0 now. Instead, you don't owe $1 anymore, but you don't have $1 either. So you have 0.
And I started talking to my kids about this, about like credit cards, that if I put something on my credit card and I need to pay it off, otherwise I'm going to have to even pay more. But at this point, if I pay it off every month, I still owe that amount. So when I get my check, guess what I have to do? I have to put that money onto my credit card. And because that's really a negative number for me. So you can talk to them about this different ways. And like she said, if I owe someone, you can talk to them about if I do my chores or I don't do my chores. Maybe I have to pay my mom if I don't do my chores. This is another way to talk to them about this. So let's say that mom says every day you have to take the trash out, or every day you have to feed your dog. And if you don't feed the dog and I have to feed the dog, you owe me $1. But if you feed the dog, I'll give you $1. So you can talk about those kind of things and say on Monday he feeds the dog. On Tuesday, he feeds the dog, but on Wednesday, he doesn't. Now, how much money is he going to get this week when he could possibly have got $3? Instead, he's only going to get how much? $2. And we can talk about that's actually a negative number for the Wednesday. So
anyway, this. We're still going.
Okay.
Looks like it from here.
I'm going to just minimize that for right now and we're going to go. Okay, we hope we're still working. So the next thing that we're looking at is a positive 3. Of course, here's my positive 3. And it's a negative 2. So again, in this case, what am I going to do? Well, we talked about zero pairs and how they cancel each other out. So if I got a positive and negative, I'm going to put them two together. They're going to zero out. Positive and negative, put them together, zero out. I have one positive left. And so that answer would actually be 1. One of the things that helps my students with this is every time I had colored pencils on my desk for my students, and any number that was a negative, I went ahead and made them either highlight with a red, or they would just go ahead and make that number red over top of it. So if they were working on cards or worksheets, if they were doing anything that was a negative, they went ahead and made red beforehand. That way it's a good visual that
like
that
that
number
idea.
needs to be red.
It really helps them understand that that's, okay, I got to use the red tool when I'm working with that number.
And that's just a good strategy for them to have, because sometimes, like I said, it's just I'm overlooking that negative. And if I go through beforehand and I make all of those red, then it really puts it in my mind that I have to remember that's a negative number. So for your kids who struggle with sometimes just seeing those, we have a visual processing issue, this is a good way to do that. So the next one is negative 3, and I'm going to add positive 2. So again, at this point, I'm zero pairing out, and I have negative 1. Because this is red, it's negative, so it's negative 1. It's a good way for our kids to remember this. Now the next one, I have negative 3 plus negative 2. Do I have any that are different colors where I need to zero pair out? I don't. So I have 1, 2, 3, 4, 5, negative 5. So my kids would know because of the color, and they may even want to write those in a red color, and that's fine. Now I talk about the pattern that they see. Well, I had 2 here that were the same colors, right? They were the same, positive and a positive, and I added them up and I got 5. Well, I had 2 here that were different. I had a positive and a negative, and I got 1. What do you think's happening? And so we talk about what's happening each time, and they were like, well, this was the same as subtract, and they'll do the same thing here. Well, but here it's negative 1 instead of 1. So what's happening at this point? And we'll talk about looking at the size of the bigger number. But remember, I worked through all of this before I ever get into teaching that procedure that we tend to teach very early on, and they don't understand why it's happening.
They have to discover the rules on their own.
Yes.
Because if we teach the rules, they don't get the understanding.
So again, we're going to do this with subtraction. So we did this with addition. I want to work through it with subtraction, and then we'll mix the two together. So in this case, I've got positive 3. And I am subtracting. Again, I can go through and I can write with my red crayon just to make sure that they know, or my red marker, whatever it may be. Oh, no, that's a positive. Yeah, let's go back over that one. Sorry, guys. It's all that negative.
That
Subtract on
subtract
there.
sign can be confusing, can it, sometimes for them,
can.
even for us. It does throw our kiddos for a loop sometimes, though.
And we got to remember that. So, okay. So now that I've got that, and we've got 3, and I'm taking away a positive 2. Now, can I, at this point, I've got 3. Can I take away positive 2?
Yeah, you've got 2 there. You
I've
can
got
take
2
away.
here. I can take away. So now I've got what? I've got 1, right?
Mm-hmm.
Now, the
And
next
it's black,
one,
so it's positive.
it's
Still
black,
positive.
so it's positive. So I've got 3 here. Can I take away a negative 2? Do you see 2 negatives I can take away?
I don't see any red.
This is why 0 pairs are so important. I'm going to build a 0 pair so I can get some negatives. So here's 1 0 pair, here's 2 0 pairs. Do I have 2 reds now?
Yes.
So I can take away 2 reds. How many do I have all together here?
Well, now you've got 5.
Now I've got 5. Now this is really important for later when we start talking about this. So now I've got a positive, and I'm going to put positive 5. We're going to put a positive 1 here too. They don't have to. That's not required, but sometimes it helps our kids to remember. All right, now I've got negative 3, and I want to take away positive 2. Do I have positive 2 there to take away?
I don't see any black.
So now I want to create 0 pairs. There's 1, there's 2. Do I have positive 2?
Yes.
I do. So now I can take away a positive 2. What do I have?
Now you have a negative 5. 5 red.
So I'm going to actually write this one in negative. Now I have negative 3. This is the coolest because we don't have to do all this stuff later. Can I take away a negative 2?
Sure.
And so I pull those negative 2, and I have negative 1. Now at this point, when I'm looking at this, I talked to my students about the fact of I had both that were the same. They were both positive. I was able to subtract. I just took them away, right? What did I have? A 1. Because I had 3, I took 2 away. I have 1. In this case, I ended up with a positive 5 because I was trying to take away a negative 2. Well, the issue with that is, and I'm going to show this on the bead string, if I've got positive 3, I can't take away a negative 2. I have to build that, just like we talked about before. And so if we build that, there's that one, there's that one, I can take that away. What am I doing? If I'm looking at this on a number line, which I could be, what I talk to my students about is, and this is where that comes in, this is 0. I've got 1, 2, 3, and 5. Now over here, I'm just going to go to negative 2 here. So negative 1, negative 2. I'm going the wrong way here. All right. So at this point, I'm talking about the fact that where am I at? I'm at positive 3. The subtract sign, typically when I'm doing subtraction, I'm going this way, right? Well, in this case, it tells me to kind of turn around. And I'm going to go the opposite way because it's got a negative on there. So I'm going to go the opposite way. I'm going to go 2, and I end up at 5. So we talk about that. Why? Because I can't go this way because at this point, I don't have those to take away. So I have to build those. This becomes kind of a little ghost over here that I'm going to be removing away. Now, for this one here, we've got negative 3. So I'm going to put these out. And I'm taking away a positive 2. Now, in the same sense, where am I at on this point? Because I want to do both.
Negative 3.
So I'm at negative 3. So this is where I'm at. Can I take away a positive 2? Do I even have positive 2 to take away? I don't. So I have to build a positive 2, which means I've got to also build what? A negative 2.
Mm-hmm.
So if I build those negative 2 and I take away my positive 2, again, I'm going to be turning around. In this case, I'm going to be going and I'm adding to it, right? So now I can take away that, and where am I at? I would be at negative 5. Now, for this one here, I've got positive 3, negative 3. can I take away -2?
Yeah.
I got those -2s. I can take them away. I can go back -2. I'm at where? I'm at 1. So, kind of things that you can talk to your kids through, walk them through it so they understand it. And again, you can do this on a number line, on a balance beam, but what you have to do on the balance beam, and I'm just going to put this in here, is this has to be negatives, these have to be positives. And if we did that, and you could do this, if I was doing, I've got 3, 1, again, very similar, I've got 3, can I take away 2 of those? Sure, 1, 2, I'm at 1. If I've got 3 and I need to take away -2, I can't do that. Again, this is where that 0 pair comes in.
0 pair is very, very important. Have you noticed how many times she said that? We have to make, the kids have to understand what 0 pairs is. That's why I was saying that example about owing somebody $1 and then finding $1. You can't keep that dollar. You have to pay pay whoever you owe, so you end up with 0.
So again, here is 1 0 pair. Oh, I added that one right on the top of the other one. I didn't see it. 1 0 pair. You didn't want to stay. All right. And 2 0 pairs. Now we've got this. Now can I take away at this point 2 negatives? If we said this side was negatives, I can take this away. How much do I have? And I've got my +5. So we want them to see those. We want them to be able to see this. And one of the things that I didn't change my numbers really on there. I mean, you can take a red marker and put it on there if you've got one of these. But if you've got just a pipe cleaner, you can just put the red pipe cleaner at the top so they know these are the negative side. That helps too. So again, like I said, that's just part of that part. Now, we'll walk through. I'm just going to do the multiplication here for you guys today because we're running out of time and I know it. And I want to get to some others. But this right here says I've got 4, and I'm just going to draw these. I've got 4 groups of 2, right? So 4 groups, and this gets into that. If I was using the mat, I would make them build this. But for our purposes today, you don't have time to.
This is the semi-concrete that we talked about earlier.
I would have them to truly build this, and I would have them use Unifix cubes, and they would build 4 groups of 2.
Build them in black. Oh, right.
Yeah, I gotta build those in black. So she's gonna build them for me.
Yeah.
So we got 4 groups of 2. All right, so what's my answer?
Well, looks like, if I get it built here, looks like we've got 8 altogether.
Put these over here, you can build. So we've got 8. Now the next one says I've got 4 groups of -2. So I've got 4 groups of -2. And so my answer is -8. Next one. This says I've got I'm subtracting a group of 2. That's really what it says. I'm taking away a group of 2. What we haven't talked about yet is the fact that this could really be, I'm taking away that group because I've created 0 pairs. So if I'm taking away 4 groups of 2, I've created my 0 pairs, right? And I'm going to subtract.
You're going to take away the positives.
I'm taking away the positives. So at this point, I could look at it like this. I've created my 4 groups of 2s, right? And I'm taking away the positive, which means I'm left with the -8. So this is why I've said all this time, the 0 pairs are important because we could be building those. Now, and it's the way that you talk through it and have the kids to talk to it. This one says I can't have negative groups because they just wouldn't exist. So this one says I'm taking away 4 groups of -2. So if I take away 4 groups of -2, I have what? I have +8. Now, again, after we've done this and they see this, we can start talking about the pattern you see. If they had the same, if they're the same, they're both positive, I get a positive number. If they are different, I get a negative number. If they're different, again, I get a negative number. If they're the same, negative and a negative, I get a positive number. So you can start to see that and build that pattern. Let's kind of move on to some others because you may be working on different ones with your students. So we're going to walk through just building an expression. Now, I love using the algebra tiles for this, and you got to let the kids play, kind of play with your tools for a few minutes. Okay, you can't just let them have the tools and expect them to know. Give them a few minutes to play. Let them see that this right here does not match up with any of these because the size of it is sum and a number. It doesn't exactly match. If you notice, it's a little bit in between.
These algebra tiles are the coolest tool ever.
They
I
really
have to
are.
say that when I wasn't aware of them until I started working here at KVEC and was introduced to those, and I had such an aha moment whenever we started working on this. I thought, well, that's why that works, because I was taught a procedure. I'm a procedure gal. Teach me the procedure and I can do it. But I didn't really have the understanding until I saw these algebra tiles. And that's sad. It took that long for me to have that understanding.
So here's the thing. This does fit perfectly here. So this is 1. These little ones are 1. In this case, it's a negative 1. I can flip it over and it's positive. The same thing here. This is negative x. This is a positive x, okay? And then if you notice, we have these bigger ones that this actually fits on here and here because this becomes x squared. Isn't that cool?
That's cool.
So I really like these for that purpose. So if I'm letting my kids, I'll let them experiment for a little while. We talk about this is x squared. This is the reason why, because it's an x times an x. So this is x squared. This gets into that 2-dimensional. I like that part too.
Mm-hmm.
So we're going to talk about the fact that this is an x and this is a 1. So we're just doing expressions right now. If I said this was negative 2x, so of course I would have negative 2x, because that's what those are, plus 2. 2 is positive. So that's what that would look like. I have modeled both of those expressions for our students. Now this is really important because later on you'll have some that will look like this right here. You'll have negative 2x plus 1x plus 3, okay? And if this is the case, you got negative 2x plus 1x, all right, plus these 3. And this is where we talk about like terms. Do you see anything that's alike there, Vonda?
Yeah,
They're the same size. Those x's are. What if we talked about 0 pairs already?
Oh yeah, I see a negative and a positive, so
I can actually remove
0 out.
those and they become 0 pairs. And now I'm simplifying that expression. What do I have?
I got a negative x plus 3.
Yeah. So see how easy that is for our students to start to see those.
I love how visual these algebra tiles are.
I do too. So this is really important for our students. And they can, you may even have a problem that looks like this. And these get really, like I said, they're kind of fun. And let's say it's got 2x plus 2. So my kids would go under here. They would say, okay, 4, because sometimes this happens, 2x. We're going to put that 2x there, plus 2 more. Now, they will not always see this. But I can say, now, do you see anything that look alike?
Yeah.
So my 2x, right?
Mm-hmm.
Keep those over here. So now if I'm simplifying this, here's my 2x. And these are the same, right?
Mm-hmm.
I don't even have the 0 pair out. So 1, 2, 3, 4, 5, 6. And I'm just making my 6.
Of course, it's important to note that this is just an expression, right?
This is just an expression.
There's no equal sign, Steph.
No, there's not. But if you think about it, I have to simplify that. I gotta know what it looks like. I'm still gonna build those expressions. So sometimes we don't think about building expressions or even having the kids, we just expect them to know what those like terms look like inside there. And they may not. Again, if I've got negative numbers, I'm gonna use that red coloring and I'm gonna go back and I'm gonna put that there so they remember that these need to be turned over and they need to be read. But that's just some of the things that I can do to help my students.
That's why it's so important that we use red here, red
Yes.
over there. We're really hitting home that red is negative with our tools because she was setting you up to be able to use these algebra tiles.
Mm-hmm.
And that's what you do for your kiddos. You let them explore these tools when they're working with just integers because that is what leads them into algebraic thinking.
So let's do a couple of linear expressions, equations, because I'm not for sure we're going to have a whole lot of time to do some others. So again, I'm going to look and I'm going to say, hey, is there any negative numbers here? Well, I see one right now. This is where this is going to be important for our kids to understand what subtract really means. I may not always have a positive. I may have a positive 3 here, but what does that really mean for me? So at this point, if I've got X and I'm taking away 3, I can build that, can I?
Mm-hmm.
So let's build 3. Well, if I build 3, what else am I building here? A 0 pair, right?
Mm-hmm.
So if I build 3, this is what 3 would look like. In this case, it says I'm taking away 3. Right?
Mm-hmm.
So that's what it's going to look like. They'll understand later that if it's just subtract that number, it's subtracting the opposite of. So that's where that gets really important for us to remember that. Now in this case, we're going to have that equal sign. I'm going to build a river. That's what I used to call it, was a river. It doesn't have to be called a river. You can just put a wiki stick there so that they don't get in between. That's another thing that we could have used here is a wiki stick, and they just stick right down there. It's perfect. Cool. And then you can use that. Now, it says it equals 5. So on this side of my balance, you've seen this already today, is 5. Now, it's a positive 5. So what do I need to do to get my X by itself? That's what we talk about. So if I need to move this to this side, what do I need to do to that? I have to build mine.
You're going to have to build it over there too.
I'm going to have to build it on both sides, right?
Mm-hmm.
I want to build the opposite because I want to 0 pair this out.
Mm-hmm.
Now again, like I said, they're going to understand that this is -3 and I'm going to have to build to get rid of it. So I'm building back my positive 3.
Oh, because whatever you do to one side, you have to do to the other side.
Exactly.
I remember that rule.
So now, if I build this to make these go away, right? Because they're 0 pairing out. I did that. Now my X is equal to 8. So see how I can see that? My X is equal to 8. Now what I want my kids to do is I want them to put that 8 in there. I want them to go back, and usually I tell them in a different color. So we're just going to write it right above this right here. And I say, no, let's make sure that makes sense. So is 8 take away 3 truly 5? Then we don't have a problem.
So that X was really my box in the primary. That was my missing number.
That's all that is. So let's do another one real quick. X plus 2 is equal to 3. So my X plus 2 is equal to 3. So we're just going to move these off. So that's what it looks like, right? Now, what do I have to do to get rid of this?
0 pair.
I have to 0 pair. So I'll build me a 0 pair for that.
Whatever you do to one side, you have to do the other side.
So I put 2 negatives there. So I have to put 2 negatives here. So again, 0 pair means there's nothing there.
I see some more.
I got some more here. And now I've only got what?
1.
1. So let's put that back in here. If my X is equal to 1, is 1 plus 2, 3.
Yep.
See how easy that was? Let's move on down because we can do this one. Sometimes we need to, again, this is the opposite of, we talked about that up there. I can build those and take away the positive 3 if I needed to. But we're just going to go ahead and say this is -3 and it's equal to -1. Now again, to get rid of this -3, I have to build a 0 pair. If I build 0 pair over here,
Do it over there.
I'm going to do it on this side because I need to make sure they're equal. And then I'm going to get rid of all of these,
I
right?
see another pair.
And I've got one here. So now X is equal to 2. So let's see if that's right. So if I've got $2
Mm-hmm.
and I owe you $3, how much does that really mean?
Well, if you give me those $2, you still owe me $1 more.
So I'm still in the red,
Yep.
$1.
Mhm.
And we can talk to our kids about that way. And that makes so much more sense for them when we start talking to them in money. For some odd
Kids
reason,
relate to money.
they
No
get
matter
the money.
how old or how young they are, we all relate to money.
Exactly.
I think it's a survival skill.
And inequalities work the same way as basically a problem does, unless it is a -X and then you flip the inequalities. So just keep that in mind. And you can actually walk through these with some of them. So I'll walk you through this one here. I don't think this one's a negative though. So we got 5 on this side. I should have probably set one up for that. 5 is greater than, right?
Mm-hmm.
You know, that great big greater than sign. 6x subtract 1, which is going to be a negative. Now, again, I'm going to do the wonderful thing of building my 0 pairs.
Mm-hmm.
Pull this off, right? Now, at this point, we have to fair share. Again, because we got 6x, right? So we try to fair share. So this x gets 1, this x gets 1.
Because we're trying to find out
This
just what
x
one of
gets
the
1.
x's
Yes,
is, right?
That's right. So this x gets 1, and this x gets 1. Guess what?
1.
1. So
Each one got 1.
this would be 1. Does this make sense? 6 times 1 is 6, right?
Mhm.
Now, at this point, what did I do with this right here? I moved him over here, right?
Mhm.
And in this case, this would have been, remember, we moved him over there, which made that a 6. So 6x and 6, right? We saw that. But in this case, 6 take away 1 is what? My answer.
Mhm.
So having that conversation with your student each time really helps our students to understand and getting them to explain it back to you. Now, these are the fun ones.
Oh, these are the cool ones.
Now, if I'm doing binomials and I've got an x and it says, this says x times x plus 1. Got an x here. We've seen this before. Where did you see this at?
This reminds me of that area model that we use in multiplication.
It's exactly where this
That's what it
came from.
reminds me of.
So in multiplication, if I've got 3 times 2, right? I can have 3 down through here, correct?
Mhm.
So I'd be 1, 2, 3. We would do that. We would start to see it built like this. Times 2, 1, 2, like this. So how many is in here?
It's going to be 6.
It's going to be 6. They would see this. So that's something that we could see in multiplication, and they would build us out. Now, in our case, this is x, and then this is x plus 1. Now, the cool thing about this is I tell my students that you have to just build rectangles. So what will fit in there?
And it has to be a rectangle.
And it has to be a rectangle. So if I put an x and an x, and we remember we already experimented with this, and we said that this x squared, right? That's the reason why it was called an x squared. It's because it actually fits all
It'll
around
fit
there.
right in there.
So here's my first one. Now I got this little 1. I'm times it by an x. What do you think is going to fit there? And so we can slide that 1x right in there. Does that make my rectangle? Does that fill in perfectly with my things? So then I move my stuff away and I say, what's my answer? Well, we see this x squared, because an x times an x makes an x squared, plus what? 1x.
Mhm.
Now, my kids will sometimes say, well, we got 3x. If they see this, They don't understand this x squared sometimes. That's an issue.
Mhm.
This way they can see, are these two the same?
Nope.
Are they like?
That's two different
I
things.
can't combine them if they're not like terms. It's kind of like I can't combine apples and oranges.
Mhm.
I don't, there's not a combination there. So these two, we can't combine. Now, let's go down to the next one here. I've got x and I've got 2x. I'm gonna need to make this longer. Okay, so you can see this. Got 2x plus 1. And now at this point, I can say x times x will make 2x and x times 1 makes 1. Now, if this had been a negative number, it would have shown up like this, and I would have said a negative and a positive we know makes a negative. That's what we could have done at this point. So we want to make sure that our kids understand that. If this had been a negative and a positive, this would have been a negative. And we talked to our kids about this. If this had been a negative and a negative, this would have been a positive, because a negative and a negative make a positive. And if we've done enough in the past with this right here, they know that. Okay, so that's what we want to make sure. Keep in mind, the big thing about math is it builds on itself all the time. So if we're missing a concept, we may have to go all the way back to that to make sure that they understand it. But for them to be able to see it, and if they build it enough, you can take them all the way through with these algebra tiles and show them, but they have to build it and they have to continue on with it. You can look up online. There's different places. Just type in teaching with algebra tiles. There's some on our website at KVEC. So if you go to KVEC and you go to, actually if you go to the holler and then you go to
Under KVEC.
drop
Drop downs, KVEC Special Education.
And then KVEC Special Education, and then you can find the math folder, and in there you can find a place that says algebra, and there's all kinds of demonstrations with these right here. So Miss Vonda, I think, is going to look for that maybe in the chat. So, oh, actually it is time for us to wrap up. It's actually time for us to wrap up. So our next thing would have been multiplying binomials, where they have those, but unfortunately we are out of time, and we were afraid of that. We overplanned, but I'm hoping you've got some really good stuff today from these. We appreciate you being here. We appreciate everything you do for our kids, because we know that schools do not run without you. And we really want to say thank you for everything that you do and what you've done in this last couple of months during this pandemic.
It's been tough.
So the feedback form is here. Ms. Vonda's dropped it in the chat, and you're more than welcome to fill out the feedback form.
Thank you.
Thank you, and bye-bye.